Hello! Today we're going on to volcanoes. So, last time we talked about earthquakes and what destruction that can cause. I hope you were able to look up some interesting videos and see the massive scale of destruction that earthquakes can cause. And today we're going to go on to volcanoes, another thing that occurs along these fault lines, along these tectonic plate lines. So, we are on page 132 in your science reading book. Let's start with vocabulary. Vent, the opening in a volcano through which magma and gases escape. Shield volcano, a gently sloping mountain made of lava released from a non explosive eruption. Cinder cone, a steeply sloped volcano made of pyroclastic material from an explosive eruption. And composite volcano, a tall cone-shaped mountain made of alternating layers of lava and pyroclastic material. If you know what pyro means, that's a prefix that means like flames, fire. So let's read on. Volcanic eruptions are another way in which pressure under the Earth's surface is released. Volcanoes are fed by a magma chamber, which is a pool of molten rock located underground. The magma travels through a long channel or pipe to the surface where it escapes through a vent. Often there is a central vent at the top of the volcano. The bowl-shaped area around the central vent is called a crater. Volcanic eruptions can produce cinders, ashes, gases, and either lava or fragmented rock known as pyroclastic material. Lava is liquid magma on the Earth's surface. Pyroclastic material forms when magma is blasted into the air and solidifies. That means it becomes a solid. There are 3 stages of volcanic activity. An active volcano is one that has recently erupted or shows the possibility of erupting soon. A dormant volcano is one that is not currently erupting, but shows signs that it may erupt again. If it erupts again, its status changes to active. A volcano is considered extinct if it has erupted in the distant past and shows no sign of erupting again. There are 3 basic types of volcanoes: shield volcanoes, cinder cones, and composite volcanoes. A shield volcano is similar in shape to that of a soldier's shield lying face up. This type of volcano forms when lava flows like a thin liquid down the sides. This type usually has quiet, non-explosive eruptions. Shield volcanoes spread out over wide areas and can be enormous. For example, the Hawaiian Islands were formed from shield volcanoes. So if you look down at the bottom of your page, there's a picture, the longest one on the bottom, and it says, Mauna Kea, a shield volcano in Hawaii, is the tallest mountain in the world when measured from its base on the seafloor to its summit. It is over 10 kilometers or 6 miles tall. But you can see that it's not like your typical pointy volcano. It's flatter, as it's not an explosive volcano that causes piles and piles and piles over time of magma and pyroclastic material. It just oozes out and seeps down over time. And so it does grow in height, but in a gradual mound-like shape. A cinder cone is usually small and erupts only a short time. Its steep cone-shaped hill is formed from pyroclastic material, which includes ash, cinders, and hardened pieces of magma. Usually at the top of this type of volcano is a bowl-shaped crater. And so a lot of times when you see, if you've ever watched scientists exploring volcanoes or doing research on volcanoes, when you get to the top of the volcano, it has a big rounded crater. And you can usually see water, really hot water or magma even bubbling up, and there's smoke and steam and gases being released, but it does have kind of that bowl-shaped crater in it. And you have a picture of Black Butte in Oregon, which is an extinct cinder cone volcano. Lastly, a composite volcano, also known as a stratovolcano, usually has alternating layers of pyroclastic material and lava. It forms from explosive eruptions followed by a quicker, non explosive flows of lava. This type of volcano is extremely dangerous because it can erupt without much warning and can destroy entire civilizations. Most composite volcanoes are located on the Ring of Fire, which edges the Pacific Ocean. Mount Vesuvius, Mount St. Helens, and Mount Fiji are composite volcanoes. So there's a picture down at the bottom of Mount Fuji. A composite volcano is Japan's highest mountain. At this time, it's classified as an active, although it has been dormant since 1707. So it's still considered active because there's still movement. There's probably still lava flow coming out of it. There's gases being released. They see activity with the assumption that at some point it's probably going to erupt again. So with a composite volcano, you have those two different things. You have the massive explosion out of the top, but then you also have lava flow going down. So it's not all just being spewed out of the top. You have it also running down the sides of the volcano. If you've ever learned about Pompeii in Italy hundreds of years ago, that was a civilization, an entire city that was completely covered from a volcanic eruption. And so they're burying it, and they have been over years, and it's almost like everything in that life was mummified, just completely encased, fossilized in the ash and lava that flowed into that city. And so it's amazing, like the things they're unpacking, because it was so sudden that it just was like an instant frozen in time. So see if you can find anything on Pompeii. It's very interesting. In the field, scientists who study volcanoes are also known as volcanologists. They often have the opportunity to visit existing places and make a difference in the world. They go to exciting places and make a difference in the world. Many volcanologists in the United States are employed by the United States Geological Survey. Some work in areas with significant levels of volcanic activity to help prevent eruptions. These predictions allow local residents to have warnings in case they need to evacuate. So a lot of things scientists are doing when it comes to volcanoes. There's not much you can do to stop an eruption because it comes from so far within the earth, and there's so much energy and power that needs to come to the surface, kind of like steam coming out of a pot. Eventually it's going to burst out as that fills the space. Volcanoes the same way, but scientists are finding how to know timing of activity in a volcano, and so they can create warnings, they can create alarms for nearby villages or towns so that they can have a better chance of surviving volcanoes that are nearby. And so that's what a lot of scientists are working on. But also they're gauging, they're doing research on the rocks. What is the magma made up of? How does the acid level of it affect the ground around it? Lots and lots of interesting things. And it's amazing. Volcanoes not just affect the area that they're erupting in, but they can erupt continents hundreds of miles away. A couple years ago, there was a volcano eruption in Iceland or Greenland. I'm pretty sure it was Iceland. And the effects of that were an ash cloud that got into the atmosphere and moved within the air movement, and it traveled for hundreds of miles over countries around the world and caused a lot of issues for a lot of countries. It caused blocking of the sunlight. It caused acidic ash to fall onto crops, onto houses, onto villages. And so that's something you can look up as well, the Icelandic eruption from a few years ago. It was either Iceland or Greenland. Don't quote me on that. But look that up and see what the long-term effects of that volcano were, not just on that continent, but also continents hundreds of thousands of miles away. So in your lab book, we are turning to 11.3. And on 11.3a, It says label the following volcanic diagram using the words in the word bank. Write your answers on the line provided. And so the different words that they have are magma chamber, lava, pipe, ash and dust, vent, and crater. So you're going to label those parts of the volcano. Okay. And then compare the three basic types of volcanoes in the chart below. Write at least two things that make each volcano type unique. So you have your shield volcano, the cinder cone volcano, and composite volcano. So you're going to write at least two details for each volcano and what makes them different from the other ones. Go back to the chapter to look up the definitions of each. On 11.3b, you have active volcanoes. Using an encyclopedia or a reliable internet source, identify 3 active volcanoes that are different in type. One must be located along the Pacific Ring of Fire. Mark the locations of these volcanoes by drawing an X to show their position on the map. Record their name, the type of volcano, whether it's shield or cinder or composite, and locate on the table below. Include an interesting fact about each. So here's a great opportunity for you to do a little bit of research. Again, use National Geographic, use any governmental sites that you know are reputable, and you can look up active cinder volcanoes or active shield volcanoes, active composite volcanoes, and then take down that information. What is the name of the volcano? What type of volcano is it? Where is it located on the earth? And give one interesting fact about it. That could be the last time it erupted, that could be what effects of the eruption, that could be what do villages nearby look like, are there any myths or legends that go along with the volcano, any interesting fact that you find. Do your best, ask a parent to help using the internet, make sure you're using reputable sites, and have fun exploring. I can't wait to see what you find out about volcanoes. See you next time.